Hey, what's up everybody? It is Mr. Boylan. We're gonna do some quick practice here, taking a look at conjugate acid-base pairs. Now, as you take a look at your notes, you've got a fairly extensive data table. I'm gonna work through a couple of the examples together, but then I want you to try some of them on your own. Okay, as I take a look at the first equation, I need to identify the acid, identify the base, and then identify the conjugate acid and conjugate base. Now, in order to do this successfully, we need to think about our definition for a Bronsted-Lowry acid and a Bronsted-Lowry base. Remember that a Bronsted-Lowry acid is going to donate hydrogen ions, and a Bronsted-Lowry base is going to accept hydrogen ions. Now, as I examine this first equation, I need to look at both sides of the equation to think about what is happening with that hydrogen ion. Who's donating, who's accepting? Recognize that HCl on the reactant side becomes Cl- on the product side. Now let's think about what must have happened in order for that to occur. Would HCl have to donate a hydrogen ion or accept a hydrogen ion? If you said donate, you are correct. So if HCl is donating a hydrogen ion, that makes it a Bronsted-Lowry acid. Now, its conjugate base, or what forms after it donates its hydrogen ion, is Cl-. These two are a conjugate acid-base pair. As we take a look at the remaining two species in my equation, recognize that we've got NH3 on the reactant side and NH4 plus on the product side. Now, in order for NH3 to become NH4 plus, it must have donated or accepted a proton, aka hydrogen ion. Answer, it must have accepted. And if NH3 is accepting a hydrogen ion, that makes it a base according to our Bronsted-Lowry definition. Its conjugate acid is going to be what forms after it gains that hydrogen ion. In this case, NH4 plus. So our second conjugate pair is ammonia and the ammonium ion. Okay, I'm going to skip down a few. Let's take a look at this equation here, the reaction between the hydrogen carbonate ion and hydroxide ions. Again, don't panic when you see equations like this. Many times we're simply looking at a net ionic equation. So again, let's compare both the reactant and product side and think to ourselves, how have our reactants become our product? Who has donated a hydrogen ion? Who has accepted a hydrogen ion? So as I look at and compare HCO3 minus, or hydrogen carbonate, to CO3 2 minus, let's think about how that has happened. Has HCO3 minus donated a hydrogen ion, or has it accepted a hydrogen ion? Answer, donated. So our Bronsted-Lowry acid in this example is HCO3 minus. Its conjugate base, or what forms after it has donated its hydrogen ion, is the carbonate ion, my first conjugate pair. Let's now take a look at what remains, the hydroxide ion and water. Again, think about how they compare. The hydroxide ion, OH-, is acting as a base. In order for it to become water, it must accept a hydrogen ion, and by definition, makes it a base. Its conjugate pair, in this case, will be water. Boom, our second conjugate pair. All right, I'm gonna skip down, do one that's a little trickier. All we're given is the acid and the base. We have to come up with the conjugate pairs and then also write the equation. As I take a look at my acid, I've got nitrous acid, HNO2. I'm told it's the acid, so it must be donating its hydrogen ion. So let's think about what's going to be left after it donates a hydrogen ion. NO2 minus is what's going to be left after the hydrogen ion is donated. So my acid and its conjugate base. Looking now at H2O, we're told that it's acting as a base or a proton acceptor. So let's think about what happens when H2O accepts a proton or a hydrogen ion. It's going to become H3O plus. Here's my Bronsted-Lowry base and its conjugate acid pair, or what forms after it has accepted that hydrogen ion. Now let's write our equation. We've got nitrous acid, HNO2, interacting with water to form hydronium ion and the nitrite ion. Okay, that'll do it for this video. I encourage you to practice more on your own. Have a fantastic day.